Okay. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fahmi bin ZULKIFLI from class IAC 5B. Now, I will demonstrate exercise 1 for this Labview assignment. Okay, for overview of the task, this exercise is about generating a sine wave using this simulate signal function, displaying it on a graph, and using a compression block to activate an alarm indicator when the signal exceeds a limit. Okay, let's begin. Okay, first I'll create project and then I choose blank VI. Okay, first I start with begin by placing a while loop on the block diagram. I choose from function palette. Okay, inside the loop, I insert the simulate signal express VI and configure it to produce a sine wave. Okay, I search using quick drop. For setting, I change to simulate equation timing. Okay, I do this because I want create a single waveform graph indicator to display the output. I also create control for the stop button. That I change to front panel to put the slider control. Okay, vertical pointer slide, and then after I put this, I change the name to the from I change to the limit. Okay, next I put the LED, boolean LED, and then I change the size to the bigger. It's easy to see. And change the name to the limit. For LED, I change from boolean to alarm. For this control and this LED, I just change the name. For setting, I don't change. Okay, then I turn to block diagram. Setting the amplitude 1 to 10. Okay, then I choose the greater than. I choose greater, and I change compression input from value to second signal input. And then I wire the sine wave and the limit into a greater than compression block. Okay, I test this because I want to make sure this connection is it right or no. So I found a shortcut to move the wrong wire. I use Ctrl B to move all error wire. Okay, this I connect from similar signal to greater, and also combine the limit, and finally I connect the compression output to an LED indicator, which means alarm. Okay, why I touch the symbol light, because I want see the flow from signal until alarm LED. Okay, now I will run and put the value. Okay, can we see I put the limit is 5. So at the sine wave, after sine wave limit reach number is 5, the alarm will light. So under 5, the alarm will close. Okay, I change to the maximum limit. As we can see, the alarm only light when touch the maximum limit. Okay, this I just test the random number. Okay, thank you. Okay, for real world engineer application, this method is used in systems such as temperature alarm, vibration monitoring, overload detection, and industrial process control. For ending summary from this exercise, I learned how to generate signal, to connect the wire component, and build a simple warning system in Labview. Okay, this is all from me for exercise 1. Thank you. Hello, my name is Fahmi bin ZULKIFLI, and now I will demonstrate exercise 2. Okay, before that, I want to explain the overview of the task. In this task, I show how to create a simulate DAQ device in Max and use the DAQ assistant in Labview to read analog voltage data. Okay. First step, I open the Max. After that, I create a simulate PCI 6221 device. I choose M series DAQ and I take PCI 6221. Then I verify the signal using test panel. I follow the slide. It use 100 and start. Okay, after I setting all in Max, I open the Labview. Okay, first we start with create blank VI. First, place a while loop. Step, place while loop. Okay, for this exercise, I choose while loop with button, so I doesn't do the add control. And then I insert the DAQ assistant. Okay, this I configure it to read analog input from voltage. I choose A0 because I setting at Max is A0. Okay, after that I create the graph indicator to display sine wave. And then I search the add a statistic vi. The function is to calculate mean, maximum and minimum value. Okay, before that I put time delay and I setting 0.1. I put the time delay because the loop updates smoothly. Why I choose 0.1. Okay, let's set up for statistic. Minimum, maximum and minimum. Okay. The data I create numeric indicator, so each mean, maximum, minimum can display data. From the input signal at statistic, I wire from data to signal. I set up perfectly because easy to see a different mean, maximum and minimum. The next step is I save to my device because after I save, it can run smoothly and get the data. The data in wave in graph indicator. Okay, next step, I search the plot diagram right to measurement because I want get a real data in Excel maybe. Yes, I setting this for the Excel. I also connect the signal to data because I want get the same data to the statistic and same data to right to measurement, which in Excel. I use Excel. Okay, we can see the data and Excel. Okay, as we can see, we can get the file. The file open with the Excel. Okay, as we can see, the result in the Excel. Okay, we can get from voltage, very many data. Okay, for real world engineering application, the EQ system are used for reading electrical signal from sensor such as temperature, pressure, humidity, vibration, and current sensor. For ending summary, I learned how to simulate hardware, collect data, and analyze it using Labview. So from this exercise, I can get many info or many data from Labview to another app such as Excel. Okay, that's all from me. Thank you. Okay, Assalamualaikum. Let's continue to exercise 3. Okay, first, my name is Fahmi from class IAC 5B. I create this video to demonstrate for exercise 3 using the MathScript node. Okay, for overview of the task, this exercise generate two signal, add noise, and use a moving average filter to smooth the signal. Okay, let's begin for the step 1. Okay, first create the blank VI. Okay, on the front panel, I put 3 numeric control. First, I name is desire of filter length, which mean the reduced noise. The second, I rename is flow, and the third, I rename as FHIGH. Meaning flow is such as input, phi is meaning like output. Okay, then I put first waveform graph. I rename this is low frequency component. I put 4 waveform graph. First is low frequency component. Second, I rename as high frequency component. Third, I rename as input signal, and last I rename as output signal. Okay, then we move to block diagram. I arrange after I arrange, I put MathScript node. Oh, before that, I used my script note in 2022 because the current Labview, which means 2024, doesn't have the Math script note. Okay, for the coding, I use as like in the slide. Okay, next step, I add input, 3 input. First, M to desired length of filter. Second, the input is flow, and third is 5. These 3 input lie in this coding. So I connect the input M to desired length of filter, input flow to flow, input 5 to 5. Okay, next step, I add the output. First output is S1. It's like in the coding, S1 equal to cos. Second output is S2 to third output is input signal, and last output is output signal. I connect from in the coding, this connect S1 to low frequency, S2 to high frequency, input signal to input signal, output signal to output signal. Okay, for the coding, I change a little bit because I want a perfect sine wave. Because I use the coding in slide, I doesn't get the perfect sine wave. Okay, the next step is input the while loop with button stop, and then I put time delay, and I set 0.1. As we can see, the coding a little bit different. Because I already test the coding before, and the sine wave get nothing change, and after I change the coding, I get a perfect sine wave. Okay, next I open the prop. The prop is meaning like we can get the value from the desire of length, flow, and pipe. Okay, next step, I run the VI. After I run, I adjust the filter length and frequency to observe changes. I try the 2 of coding. The coding in this slide, we can get the value like this. The data is 0 because I doesn't change numeric control. Okay, this the update data. Yeah, update coding. Sorry. Okay, after I run, I get the different value. As we can see, the sine wave. Okay. The sine wave we can get perfect. Okay, for the flow is meaning low frequency component. For the fight is meaning high frequency component. Desired length of filter is to reduce noise from the input signal. The input signal is get from low frequency component, and high frequency component add noise. Okay, that's all. Okay, for real-world engineering application, this filtering technique is used in vibration analysis, biomedical signal, audio noise reduction, and smoothing sensor data. For ending summary, I learned how to combine graphical programming with text-based scripting and implement digital filter. Okay, thank you. That's all for exercise 3. Assalamualaikum. My name is Muhammad Fahmi bin ZULKIFLI from class IAC 5B. Now I will demonstrate exercise 4. Before that, I want to explain about overview of the task. The purpose of this exercise is to simulate a signal, perform spectral analysis, and generate an HTML report automatically. Okay, let's begin for the step. Okay, first we create the blank VI. First, I place the simulate signal VI to create the test signal. I setting at noise and integer number of cycle. For noise and amplitude, I setting to 0.1. Then I add the spectral measurement VI and configure it to perform FFT analysis. For the setting, I choose the result is linear, and for measurement I choose power spectrum. First step, I connect sine with uniform to the signal in measurement. Next, I place the report express VI and choose HTML. For setting, I choose the HTML as the report output. I change the title to data monitoring. Data report. National instrument. For the comment, I follow like in the slide. I setting all this like in slide. Okay, after that, I wire both the time domain and frequency domain signal to the report generator. Before I run, I save in this folder because it make me easier to open the HTML. I only put the setting in block diagram. Okay, when I run the VI, Labview can create a HTML file that contain all data. Okay, as we can see, we can get two data. Okay, first is sine wave. Okay, as we can see, we get the data from HTML at website. We generate a title, author, and time the report. And I run again, we can get the data again in this folder. Okay, that's all for the step-by-step demonstration. Okay, for the real-world engineering application, this method is used in laboratory testing, automated reporting, QC documentation, and vibration analysis report. For the ending summary, I learned how to generate structured report, which is important in engineering documentation. Like we can get the data at the website. It's easy. We get the data from the website from the app. Okay, thank you. That's all for exercise 4. Okay, Assalamualaikum, and my name is Muhammad Fahmi bin ZULKIFLI. Okay, I will demonstrate the exercise 5 and last video. Okay, for overview of the task, this task demonstrate how to publish a VI online using remote panel. Okay, let's begin step-by-step demonstration. Okay, first I open the exercise 2 because this exercise continue from the exercise 2 and get the data from exercise 2. Okay, for first step, I open tool and says web publishing tool and select the VI from exercise 2. because we won't get the data from exercise 2. Okay, as we can see, this version doesn't have embedded system, so I only choose monitor. I just choose monitor. The function of monitor is only display a snapshot that update continuously, so the data only get at the website. So I change the title is data monitoring. For the header, I delete all, and I rename this exercise is exercise 5. Next, I save to this, and I want connect to the website. Okay, as we can see, the data monitoring is 0 because we don't set at the block diagram at the front panel. Okay, as we can see, data at front panel, also the data at the website. Okay, for this version, only can see the result but cannot control the stop button or cannot control the input data. Okay, that's all for the step. Now I will the real world engineering application. This is used in remote laboratories, IoT system, industrial monitoring, and distance learning environment. For ending summary, I learned how to use web publishing, and for remote control features, I don't try because it doesn't have at this version. Okay, that's all for me. Thank you.